Welcome. My talk is today about why Mime is broken, and okay, the screen is a little bit off. Let's see. About me, I'm a security engineer, security researcher, fellow. I'm working 20 years plus at Genua GmbH near Munich. My focus of the work is not on breaking things, but on protecting what's already broken. And I did a lot of firewall development, focusing on the application layer. I did 8 years of collaboration with academia and research projects, focusing on defending against attacks via mail and web. And I'm currently involved more in product and research strategies. I'm working at Genua GmbH. It's a company exactly 30 years old now, with 360 plus employees in various locations inside Germany. We are a subsidiary of the Bundesdruckerei GmbH, and we build security solutions for IT and OT, and our focus is on sectors with higher security requirements, so public sector, critical infrastructures, regulated industry, e-health, etc. And of course, if you want to help, you are welcome. The motivation of my research, like I said, I did a lot of firewall development at the application layer, so I had to implement application protocols, and the best way or the preferred way to implement application protocols is to actually look at the standards. Not many do this actually when implementing these protocols. But when looking at the standards and trying to find out how to implement these, the problem is that these standards are typically very flexible and very complex, and they are unnecessarily flexible and complex. They leave way too much room for creative interpretation, so there are lots of edge cases with no clearly defined behavior. There's no defined behavior of protocol errors. There's a lot of should instead of must be implemented, and they are partly conflicting with previous standards. Of course, all of this conflicts kind of with security. The result are that we have different implementations which interpret especially edge cases in different ways, and this can of course be used by attackers. So if the analysis system, like a firewall, interprets the content differently than the end-user system, like in our case the mail user agent, then we can pass attacks through the firewall. So the focus of my research in this case is Mime. Mime is kind of a standard for rich mail. So what we have today, structured mail, binary attachments, non-ASCII characters. And what I explore here is how to use different interpretations of Mime to bypass security systems. So these are analysis in mail filters, firewalls, intrusion detection systems, antivirus, versus the interpretation by mail user agents or web front ends. I'm looking into bypassing malware detection by content using the ICAR test virus, and bypassing detection or attachment filtering by file name. So if we can make the firewall believe that we have a different file name, it's not a .exe, it's not a .zip, then the firewall will pass through the mail. There's similar research for HTTP1. There's all this portswigger stuff about HTTP desync attacks, which are targeting the server side. I did a lot of research on the HTTP side too, but for targeting clients, so sending malicious responses or unexpected responses by the server and bypassing firewalls this way. This research here was primarily done in 2015 to 2018 during a research project, but I freshly updated it to make sure that all the attacks still work, and they do. So, to explore this topic, I created a lot of different mails with different test cases. So nearly 400 mails for content analysis, or nearly 200 mails for bypassing extension blocking. These mails I exported as files or mail directory, and also as packet capture file to check against intrusion detection systems. And then I checked against several systems like various mail user agents, various antivirus and mail filter products, some intrusion detection systems in firewall I won't mention here because it's not a free one, and some libraries. Okay, short introduction into what Mime actually is. In the beginning, there was about before 1995, there was only ASCII. There were only ASCII mails. These had a line length limit of 1,000 bytes, and there was no kind of structure, no attachment or similar inside. 1996, we got these Mime RFC, which defined different aspects of how to serialize structured information and non-ASCII information into the original limits. So, binary data, structures data like attachments. And of course, like I said, this is a standard which is flexible, which is complex, underspecified, and has lots of room for creative interpretation. A year later, there were some additional standards. One is about content disposition, how to specify a file name, how to specify if the attachment is inline or external. And there is another standard for encoding of non-ASCII characters into structured data like file names or so. For some reason, they didn't include this in the original one, so they needed yet another one which implemented a totally different encoding for some reason. Okay, if you look at the source code of a mail, we see the different standards applied here. So we have the subject, which is an unstructured header field, and there we see RFC 2047. So this one, which is about encoding characters in the header. What we have here is with Q is quoted printable encoding, which means that the characters, the non-ASCII characters, are encoded in some kind of hex value. So this equals C3 means that it's a character hex C3, and then we can look in the UTF-8 encoding what this character actually means. Okay, then we have this kind of Mime preamble here, which is hidden in modern mail clients. So basically all mail clients we have today, it's only for the old mail clients. So this is everything before the first part, because we have here a multi-part mail, which is defined in RFC 2046. And we have a boundary here defined to split the mail into different parts with the final boundary here. Then we have, for some parts, we have a name. So we can have a name given in this way. We can have a name given in this way. This is actually RFC 2231, which has this kind of encoding for long file names, which we can split over multiple parameters, because, like I said, the limit for line lengths in mail is 1,000 characters. And which has this kind of hex encoding here, which looks similar to what we have in quoted printable, but again, it's totally different, because we have here we have an equal sign, here we have percent sign, and so, and for some reason they needed to make everything differently. And then we have quoted printable encoding here for the content, and base 64 encoding here for the content of the attachment. Okay. I show some selected examples of how this can be used to create edge cases, which are theoretically allowed, or especially not as they are not especially forbidden by the standard, but where the interpretation is ambitious. So, for example, in this case, you can define two content transfer encodings. This is similar like attacks in HTTP, where we have two content length setters with different values. And because we have two values here, it's not clear how this part, so this is base 64, how this gets interpreted. And depending on the mail client we use, it gets interpreted in a different way. And depends on the analysis software we use or the library. Some manage to see this and some don't see this. So Suricata IDS doesn't see the attachment, the right attachment in this case. Oops. Slight variation of this. We have one field only, but we have multiple values inside. Again, some mail clients understand this and just take the base 64 because it's the first one. No mail client actually takes the last one, but Outlook and Apple Mail don't understand this at all and just assume there's no encoding done. We can play similar games with the content. With multi-part mail, so we have boundaries here, and we can have two boundary definitions, and the correct one would be bar here. So this is the first one, and here this is as the last one, and again, depending on the mail client and depending on the analysis software, we have different results. Same thing again, one field, multiple values, and here again it switches. First, mod was on this side and Apple Mail was on this side. Yes, now it's switched, and it's the same with various software. So we here see a MVSD new, which behaves the same as Perl Mime tools because it's used inside. And then different area. The area of encodings, there's a base 64 encoding. Base 64 basically means that we have 3 bytes binary data mapped to 4-byte ASCII data. So it's taken the first 6-bit, then the next 6-bit, and so on until we have 24-bit, 3 bytes binary, and map these to 32 bits, which are plain ASCII. And if we have less than 3 bytes, then we have a padding. So in this case, we have 4 bytes here, which means we have 2 bytes padding because we have to fill in the last 2 bytes to get 6 bytes. And here in this case, we have 2 bytes. This means we have 1 byte padding, and this padding is done with the equal sign here. And the standard, or the RFC, is not clear. In this case, if what we have should be encoded in one piece so that we have only a single padding, at most a single padding at the end, or if you can actually have multiple pieces. It suggests that was maybe done this way, but there is no should, or even better, a must. And that's why we have different implementations. So we have Thunderbird Apple Mail, which just accepts that it's okay to do so. We have Mod, which just takes the first part. And we have Outlook, which, I don't know, it takes the first part and then there's garbage. And I don't actually know where this garbage comes from. And if we have a look at the analysis software or the libraries, we see that most of these plainly fail to see what major mail clients actually can do. But we have more encodings. We have quotable printable, which is in the standard too, but we have also encodings which are not in the standard, but which are actually supported by some mail clients. There is this YENC encoding, and this is an encoding which comes from the area of Usenet news. I don't know if somebody still remembers. It's some 15, 20 years ago, this time was it? Yeah, it's very efficient encoding, more efficient than base 64, and that's why it was used on Usenet to transfer binary data. And because Thunderbird can still function as a newsreader, it implements these encoding, but nobody else does, and no analysis software is able to see this. Other interesting encoding is UUN code. This predates Mime. This predates YENC too. It was used in former times in plain text mails to include some binary data. So we had some kind of file name here inside the part, and then we had this encoding, and then there was an end. And this encoding is very similar to base64, only it's mapped slightly different, but the idea is the same. And this is actually a widely supported encoding. So we have major mail clients which can do it. And we actually have major antivirus products which can do it too. But there are lots of variations. So we can have different transfer encoding times. Sometimes we need the begin and end. Sometimes you can skip it, etc., etc. And they all work slightly different. So there's lots of room for bypassing analysis software. And then we have another strange feature of mail, which is comments in mail header, also in mail fields. So the standard actually says that one can place comments with this part with a parentheses around it. In several places freely inserted, and Outlook takes this to the next level. It's basically nearly everywhere. This stuff can be inserted, and it simply gets ignored. So Outlook sees, in this case, sees bar as a boundary. All other implementations don't see this bar, and ClamF can see it, and there's this firewall which can see it, and the Python library, but everybody else cannot see this. Okay, this is about content filtering, and then we have the specification of file names. Two small examples. Like I said, we have this RFC 2023-1, which defined a new encoding for file names, and which defined how that these can be split into multiple parameters. So there is an index for the parameter, and I can split it over multiple such indexes. The order actually does not matter, which is explicitly specified in the standard. And like one can see Thunderbird, Apple Mail, Mod all supports this kind of. Outlook has no idea what the standard is at all. And the funny thing, if I use Microsoft Exchange, it even transforms this encoding, this right encoding, into a wrong encoding because Outlook does not support it. But I have this another standard, this RFC 2047, which was defined for encoding of characters into unstructured mail fields. And it specifically says that this encoding stuff should not be quoted and should not be used inside of content type or content disposition. But funny thing is, most supports this. And many analysis software supports this too, but there are several variations of the topic. So if I use some strange encodings like OTF16, it gets weird, and I have, again, ways to bypass firewalls or analysis systems. Okay, so how to apply this knowledge in the practice? Small thing, I create a mail, and I check this mail with VirusTotal. So this mail has inside here base64 encoding a zip file, and the zip file contains the ICA test virus. And like we can see, there's ground truth 38 products in at VirusTotal can actually parse this mail and can detect the virus inside. So nice. Let's see if we make a small change. We add another content transfer encoding here, and we can see the number goes slightly down. If we switch the order, it's not much different. And if we specify a content transfer encoding, which is something which doesn't exist, like XXXX, then yeah, it goes down, but there are still a lot of scanners which will simply have an heuristic and see this is base 64 encoding and will try to analyze it. Okay, small step. We don't use a single chunk for base 64, but we use actually multiple chunks for 2 bytes. So we get a padding, 1 character padding after each chunk. And now the number goes way down. And even if we take back all this stuff we did before here, is it still very low. And last step, we just add multiple boundaries here, which different implementation, and now we have no antivirus product supports it anymore. If we look at the mail in Thunderbird, we can still normally just extract it, have a look at it. And if we remove this content transfer confusion here, it's still only one antivirus product which will see this. Okay, slightly different area. DKIM signatures. I don't know who is familiar with DKIM and DMARC. The basic idea is that we want to protect us against the spoofing of the sender, and the visible sender inside the mail is inside the mail from header. And DMARC basically says that this from header the domain of the from header must be aligned with either sender permitted framework, so SPF, or DKIM signatures. And DKIM signature is actually only it's a cryptographic signature over parts of the header and over the body. And we can check this, and it's independent from the transport of the mail, so we can redistribute the mail, and this DKIM signature does not change at all, which is very nice. But the DKIM standard relies on Mime being not broken. And the DKIM standard itself is insufficient too. So there are no requirements which header fields like content type, like subject or so need to be protected. There are some recommendations, but these recommendations are insufficient. There is a way in the standard to protect header fields to make sure that no critical header fields can be added, but there's no requirement to do so. Which means that typically implementations like in OpenDKIM or so, or basically in any products we see outside, are broken. They don't properly protect the headers. Additionally, DKIM allows us to sign only parts of the mail. The idea is that some software could add some footer and the signature should be the same. And they say that there's a security problem, but nevertheless, they allow it. Okay, so what can we do? This is a mail I got about 6 years ago. And from Deutsche Post, which is a classic sender, a typical sender for spoofing. And we have the DKIM signature here, and the DKIM signature says that not the full body is signed, but yeah, only up to a specific part, like here at the end. The mail also, the DKIM signature also says that we have some fields signed here, but these are only included once. That means the existing field is including, but I can freely add additional fields. These are not included in the signature. So what I can do is here I can add another date, I can add another to header, I can add another content type, and I can freely put stuff at the end, which means with this changed content type, I have a different boundary, which means all this part up to this boundary is seen only as a Mime preamble, is not visible in the mail client today, but instead this part after that is shown. And if I deliver this mail, I can see that this part is shown, and I can see that DKIM is still okay, and the properties of mail show that the date is changed, the message ID is, I didn't know if I changed it in the previous example, but I can see for that DKIM and DMARC both pass. So, final words. Are there any solutions to this problem? Yeah, maybe. The problems are hard to fix. There are zillions of MIME implementations and scripts in the wild. These are often broken. There is no monopoly on implementations which could be used to enforce a minimal quality. We have such monopoly with browsers. One can try to block such edge cases, but this can cause unbearable collateral effects. I've seen this in the practice. There's simply too much junk in the real world, and in dubbed operation beats security. It worked before we installed the firewall. There's a way to sanitize the mails, but this can break stuff too. So it will break DKIM signatures, PGP, and SMIME signatures. I've seen this too. And ultimately, one can simply log the problems and then hope that somebody cares actually about the logs. Thank you.
So, do we have any questions for Steffen and his very optimistic outlook on MIME? So, Steffen, I have one question, and you kind of addressed it in your last slide. If I am an administrator of an email service, what can I do? Is there anything that I should do today to protect against attacks like this?
I think there's no good answer to this. Because actually we built in our product all the protections against these attacks I have shown, and we had to make a lot of these protections optional because there are a lot of junk mails outside, which are not spam mails, which are real mails, but which are actually invalid.
Okay, there's another question.
I'm loud. Hi. Have you taken a look at sometimes when you forward an email with attachments, then in different kinds of email clients or webmail clients, they get unfolded, even though it's an attachment. Have you been looking into this kind of scenario? Because I used to fix a bug in a webmail client where there's an attachment and a forward with an attachment, and they were unfolded, and this kind of helps sometimes mitigating also, or some bypass some firewall rules.
Yeah, forwarding mails is a strange thing. There are two options to forward a mail. It's the inline forwarding, it's the forwarding as attachment. And the forwarding as attachment is supposed to just put in the original mail, but one can actually modify it. And then there are different problems on top of this, because if the original mail was transferred over a path which is 8-byte clean, and then I forward this mail, and the next path is not 8-byte clean, which is a traditional path with SMTP, then I might need to rewrite everything. So it could be used to kind of sanitize, but it will then it might also break. It might break the DKIM signatures, it might break PGP and SMIME signatures.
You mentioned that you generate a lot of test cases. Are you aware of any publicly available weaponized frameworks to exploit these issues so that I can target specific setups and generate a mail that will bypass these checks?
No, I'm not aware of any other research in this area, in this depth, but if you want to start such a research, come to me and I give you the test cases and the framework to generate these.
Awesome. Thanks.
All right, that should be the last question. We've reached 15 o'clock. Please give Steffen a hand. The mind is broken.